Hidden in fragments of bone and buried in remote caves lies the story of ancient human lineages. Most of us assume we're Homo sapiens, full stop. But what if your family tree tells a more complicated story? What are the odds that a random ancestor of yours, just a few thousand generations back, was a Neanderthal or a Denisovan? The answer may surprise you. The mysterious lives of Neanderthals and Denisovans and their connection to us is only now being uncovered. It was previously thought that the other two hominin groups were a lost branch of humanity, wiped out by evolution, while we, Homo sapiens, were the sole surviving lineage. However, recent discoveries tell a different story, one where these ancient humans didn't vanish, but instead live on within us. In 2010, Svante Pääbo's team successfully published the entire Neanderthal genome, sequenced from 3 bone fragments found in Croatia's Vindija cave. What they found was astonishing. When they compared the Neanderthal genome to that of modern humans, they discovered that most people outside sub-Saharan Africa carry around 2% Neanderthal DNA. Could interbreeding between Homo sapiens, Neanderthals, and Denisovans have been more common than once believed? It's definitely possible. We know interbreeding produced individuals with mixed ancestry, but there's limited evidence that these mixes led to large, long-lasting populations with extensive intermixing. We can also get clues about past mixing from the genomes of people living today. In many non-African populations, large parts of the genome are entirely devoid of Neanderthal or Denisovan DNA. These so-called archaic deserts are believed to result from natural selection weeding out harmful gene variants inherited from interbreeding. Interestingly, many of these regions are associated with crucial functions like reproduction and immune regulation, suggesting that mixed offspring may have faced fertility issues or reduced survival. This may have led to a purge of incompatible genetic material over time. But natural selection isn't the only factor at play. The shortage of evidence could also be explained by geography and timing. Although there were points of overlap, these meetings may have been brief and infrequent, limiting opportunities for widespread genetic mixing. If that wasn't enough, climate conditions likely destroyed much of the evidence for these ancient encounters. Remember, our understanding is always shaped by the remains that survive to the present day. Consider 2 early Homo sapiens parents, one with 4% Neanderthal DNA and the other with 6%. One would expect their child to inherit 5% Neanderthal DNA, the average between the parents, but that's not necessarily the case. DNA is passed down in a stochastic process, meaning it's driven by chance. The result? Each child gets a random mix of genetic segments, meaning one child might end up with a little less than 5% Neanderthal DNA, while another might have more. But what matters to natural selection isn't the average, it's the specific DNA segments each individual inherits, and how those segments affect their survival and reproduction. We only see the Neanderthal DNA that survived, not the full extent of actual interbreeding. In statistical terms, inferring ancient mixing from modern genomes is an inverse problem. We have the end picture and need to work backwards to reveal the original puzzle pieces. But how do we do that? Enter Bayes' theorem, a statistical tool we use to answer the questions. Given today's DNA makeup, how likely were different amounts of Neanderthal ancestry in the past? Now here's where things get a little mind-bending, so stay with me. A simple thought experiment can rewrite how we think about ancestry. Starting with yourself, trace your ancestry back 1 generation by randomly choosing one of your parents. From that parent, randomly pick one of their parents. Keep repeating the process, 1 random parent per generation, until your ancestral line extends back 70,000 years. What is the probability that this random ancestor who lived 70,000 years ago is a Neanderthal? You might guess a 2% probability. After all, the average modern human carries 2% Neanderthal DNA, but that's not even close. The likelihood of that randomly chosen ancestor being a Neanderthal is much higher than 2%, since the share of Neanderthal ancestors in your family tree doesn't match the percentage of Neanderthal DNA found in modern humans. Some researchers estimate that as many as 20–30% of your ancestors may have been Neanderthal. Why the mismatch? The repeated process of natural selection was more likely to weed out lineages with higher percentages of Neanderthal DNA. Thanks to that pruning, many of their genes just didn't survive. This is a classic case of survivor bias. We don't see the full picture, only the lineages that persevered to the present day. This raises a big question. How do we find out what really happened? While our genomes show about 2% Neanderthal DNA, Bayes' approach reminds us that the true extent of ancient mixing must have been higher. We just have to correct for the bias introduced by only looking at the survivors. Easier said than done, but that's where the math comes in. If you're curious how statistics help us uncover hidden histories, check out our deep dive into Bayesian reasoning and survivor bias. Though Neanderthals and Denisovans seemingly disappeared tens of thousands of years ago, their genetic story persists in our DNA today. Now we wonder, did these ancient humans really go extinct? Or are they still somehow walking within us? Follow our series for more knowledge and insight into the fascinating history of us.